Fabricating integrated circuits requires the formation of thin films of various materials on the wafer surface. The operations used to create thin films are referred to as layering processes. These layers perform different circuit functions. Some are conductors. Some are insulators. Still others may be added layers of semiconducting material. Patterning is the most demanding and costly semiconductor manufacturing operation. There are 5 basic steps to the patterning operation. The first, photoresist coat, begins with sequential dehydration, priming, and baking steps. These are followed by the application of photoresist in a spin process and another baking step to drive off the photoresist solvents. In step 2, the critical alignment and exposure procedure, the pattern on a reticle or photomask is aligned to the wafer and then transferred into the photoresist layer using one of several different approaches. After alignment and exposure, the photoresist layer has regions of exposed and unexposed resist. Bringing out the pattern in the resist layer occurs during the development process. Dry etch takes place in plasma etch systems, where the patterned photoresist acts as an etch stencil. The doping process drives very small amounts of dopants into the wafer surface through openings created in a patterning operation. Doping alters the conductivity of semiconducting materials. The dopants create electrically active N and P-type regions in the wafer surface. Ion implantation is the most commonly used doping method. The deposition of many thin layers is needed in building integrated circuit structures. A deposited layer may be a semiconducting layer, such as silicon, an insulating material, such as silicon dioxide or silicon nitride, or a conducting layer of metal, such as aluminum, copper, or tungsten. Chemical vapor deposition, or CVD, is often used to deposit silicon and dielectric layers. Insulating materials are referred to as dielectrics. Many device structures are built on the wafer surface using CVD layers. This results in height variations that cause focus problems for subsequent patterning operations. The solution to this problem is to flatten or planarize the surface of the insulating layer, which is deposited over the structures on the wafer surface. However, the most important planarizing technique is chemical mechanical polishing, or CMP. CMP combines chemical action with light mechanical polishing. Metal layers, deposited and patterned on the wafer surface, are used to connect the individual components, creating an integrated circuit. The most common deposition technique for metals is sputtering. Sputtering is a physical process and a form of PVD, physical vapor deposition. Sputtering is similar to freeing pieces from a concrete wall using a sandblaster. Another method of depositing a metal on the wafer is electrochemical deposition, ECD, also referred to as electroplating. An important use of ECD is to deposit copper layers. An important issue in the multilevel wiring structure is the dielectric constant, called K, of the material used for the insulating layers.